you must be talking about the old XY. What? No. This is you must be talking about the old joke in Python about anti-gravity, and
Yeah.
I'm like, I'm talking about the IDE from the company that made you, and and anyway, it's a little funny. When I finally said, when I was like, trying to get it to understand that I was using anti-gravity IDE, apparently that is still considered like a beta project at Google. So it is weird because I'll talk to people about how I'm doing it, and they're like, "Are you using Gemini?" I'm like, "No, I'm using anti-gravity." They're like, "Oh, you're using VS Code," and I'm like, they've definitely VS Code is open source. Like they've definitely got a GUI that they're using, but the multi-agent feature, because I'm using three things. I'm using Gemini, which is obviously their kind of chat GPT, and I'm using their reasoning model, right? So it's like the 3 Pro, right? Then, but I'm actually doing most of the work with the IDE, which has this multi-agent feature, right? So you can actually start multiple conversations, and the prompts. It's interesting how some of the prompts create sub-agents, and I'm trying to understand how that differs from me creating 3 agents, right? So it's just like if it has 3 sub agents, like so they share some context in some way that's valuable. And I'm again, there's no way to look any of this up. Like um, there's no manual for this. There's like some YouTube videos from the Google developers, um, and uh, but then I'm also using Jules, and it seems like most people haven't heard of Jules. But Jules is another Google project where it's an asynchronous agent. Um, the advice the advice that Gemini is giving me is that I should be using Jules repo wide, okay, and I should be using agents and the multi-agent functionality for developing features, and obviously Gemini for kind of like big picture reasoning kind of things. So for instance, like I tried setting a some coding standards and basically code review, code audit, doc string checking, um, unit tests, uh, the use of units in all the um, appropriate use of units and unit checking, um, since I'm doing physics, right? Uh, as I said, as a Jules task. So it was, like again, like I would love, I'd love some guidance in terms of how to best, structure this. Um, I think I come back to, and I sent you there was a Hacker News story on Gastown. There was a couple of Hacker News stories on Gastown. And so apparently some of the criticism of Gastown, which is the Claude Code multi-agent, it takes a whole town to raise a child. Um, uh, I've been like, wow, this is like an excessive use of, wow, we're going to burn the planet a lot faster if you create 40 agents to do this. Um, at the same time, like I can also see you can also see the benefit of it in terms of um, having that kind of, you know, communication, having particular agents that are just there to like um, help with the communication between agents, or like help with the standardization. Like, hey, there's a new function that you should all be using, and like it's hard to get across. And sometimes I'm like, you know, if I mistakenly start a new agent, it will immediately start to try and pip install stuff. And it's just like, no, I've tried to make a blanket rule. Like anytime you want to install things or do any Python work, like use UV. Um, I'm still like, how do I set global rules for all my agents so that like, you know, when it sees a PyTorch project, I'm like, don't pip install PyTorch. Like on a DGX Spark, you need to use a NVIDIA NGC container. I'm like, how do I? I want, there's like rules I want all the agents to have. So I'm trying to figure out how to use the agents.md file. Again, it's like coming back to this thing we definitely talked about last week in terms of, you have your agents creating documents, markdown files that are they call artifacts that other agents can find and read and learn from in terms of ongoing progress, or rules to live by, or things like that. you um, but I do feel like I'm you know just throwing a lot at the wall and seeing what sticks. I mean, in the sense of like I'm trying to structure it, but um I feel after a certain amount of time, like I'm always like doing, I'm like trying to use Jules to then, you know, do a pass across the recent development and make sure that it's still that it's actually complete, right? Like how much do you check? Um, every so often I'll find in a walkthrough that like there's no function, is just a placeholder or something like that, right? Like and so what you're looking at there is like one of like agents created something, but it didn't actually end up getting used by the output requirements that I had either specified in the prompt or etc. Right? So it's again, it's just like you 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 you're doing development so fast that things can actually just get set up. Um, uh, yeah, and the other thing being funny is just like how many temporary test files and things like that. Like I keep saving to GitHub a lot of just checks and text outputs that have been generated. Um, but again, it's remarkable how fast it can create something that you could do yourself, but would take you a lot of time to look up stuff and to check what the syntax is on this. And it really is like having a an assistant with just an incredibly broad range of technical skills. But getting to the point where it's just like we'll yeah, be able to get in touch with some researchers and be like, hey, I've been testing this tool. It can do in seconds what takes minutes or hours, and it produces uncertainty estimates, and it excuse me. Um, it's really interesting. But I'm also thinking about like how do um I mean, I don't know if like reaching out to Russ or something like that, be like, okay, like, I've I've really used Google to create this tool. I totally stand by the testing and things like that, but like, how do I talk about this development? you know, or is this super common now?
Yeah, it's interesting. Just kind of being able to take some of the harder tasks and push them off to an assistant and automate that. But then we have to, of course, describe how it's being done. And, like in a methods section of a paper, we usually describe all of the steps that happened and it all has to be documented. I guess that's kind of the point of better science, is that it's more transparent. But it's also better science in the sense of, getting things done and getting things to run. So there is that sort of tension there. And, it's always nice to know how something works, but if you can like implement it, well, it's kind of like a container, right? If you have something in a container, I can give you the container and theoretically you should be able to run the whole thing in the container. You don't really have to tell me every step of what's being executed in the container, just as long as I have that artifact. So, I mean, it's really interesting.
Yeah, yeah, and um, I mean, I still think that the development cycle is very much like working, you know, working regularly, right? Which is, you build up a framework, and then you potentially doing some kind of like unit tests as you build things, but you finish that with a now let's try this on some synthetic data, where I know what I should be seeing, um, given the set of operations, and then now let's try it on some real world data where there's realistic noise, and but I go off of uh, this is a data set with known problems, or with these are parts of the I go to particular parts of the brain where you have very known kind of fiber orientations and things like that, like etc. You know, um, yeah.
Yeah.
But it's still coming back to that better code, better education. Um, uh, uh, I'm absolutely learning to like again, like this isn't just like go create a framework for diffusion MRI modeling, right? Like you're stepping through all of this, and uh, like it's actually been really interesting of how much learning I'm along the way. But yeah, and these are on some topics that like have been my research area for a long time. Like yeah, and some of it is that like I've never had the ability to like kind of wade through so much technical math and examples so quickly, but with commentary. That yeah, I really think that like this can be practical for teaching purposes.
Yeah. Yeah, I've been thinking about, and I've been doing a number of different things with different AI tools. In the next couple weeks, I'm going to maybe give some demos of this, and maybe it'd be nice if you give a short demo on it too at some point. But to be able to kind of do things that maybe were very hard before, we couldn't do before, that are a lot easier, and kind of walking through some of the parts of that and how that's implemented.
Yeah.
So, I mean, this is some of it's research, some of it's like, other types of things you'd like to do. But there are actually a lot of local tools, like on local machines, that you can use that are actually quite impressive. The problem, of course, as you've mentioned, is that the documentation isn't always there. So you have to kind of feel your way around it and kind of get a sense of how it works and everything else. So there's this sort of you want to be replicable in what you do, but then again, you want to also try all these different combinations of things to get them to work. So you have to figure out what you can get to work, and then how you make that, into a repeatable pipeline that I can just say, here, I'm going to hand this off. This is the way this works, and it'll basically give you this result. So it's it's hard to do, because again, we've talked about this, the different strategies for doing this. So, but yeah, I don't think I'm going to do that this week, but maybe in subsequent weeks, or maybe I'll do it as like a separate thing on the YouTube channel where I kind of walk through some of these tools. So yeah, I mean, that'd be interesting to see maybe like some of the outcomes of some of the stuff you're doing too. Just kind of like, what is it simulating, and what kinds of interesting things can you build with that? Um, I assume you're really kind of working more on kind of research questions.
Well, it's I took a project called diffusion. What's it? Diffusion microstructural imaging in Python, which was so this is a tool for fitting tissue models to diffusion data, right? So it's just like when you're looking at how water's moving, you're testing how water's moving in 64 directions, and it allows you to get to kind of make to capture the ellipsoid, if you will, of like where is water free to move in this direction, and where is it restricted in this other direction. But then as time's gone on, people have got more sophisticated with that, and they've recognized that you actually are looking at multiple water pools, right? So you have interaxon water, you have the extra-axon water, and you have free water. And there's even techniques now where they're talking about the soma water, and by again, not to get it too into the diffusion sequence itself in terms of how they're doing that, but they're making it such that they can actually separate those water pools potentially, right? So I'm not so much answering a particular question at this point as what I'm trying to do is make a tool that I was in the analysis group at Finland. So so my advisor leads the FSL team, which is like the software that's the most widely used for MRI research, MRI processing. Yeah. And in my own work in psychiatric neuroimaging, like certainly, people come up with things like we expect, in these patients to see these changes in, tissue composition or something. And that's what this allows you to do, right? Or this is certainly trying to get at like how to infer tissue um, tissue structure from MRI. I'm kind of focused on a particular thing, which is how to do that in a Bayesian way that allows for model comparison. So I can say is at each voxel, what is the best model for the tissue there? And yeah, like trying to give it that, trying to give the tool, a computational physics tool, a statistical model comparison feature. It'd be like if you were pinning me down on uh, a goal with it. But that allows you to ask a lot of questions, like, and they don't have to be psychiatric, like they could be. I think it would be really interesting to look at, brain tumor data. Like how useful is this in terms of capturing the heterogeneity of the tumor, right? Because again, that can be really useful for understanding the kind of severity and or like pre-surgical planning, right? It might be one thing.
Yeah, that's that's interesting. Yeah, so it's definitely worth revisiting and or being a little bit more like hands on
Yeah.
in the group here.
Yeah, I know. And I would love to know. I mean, this could be one of those things where it's just like if there's no manual and there's no kind of instruction, then perhaps like trying to start some sort of group for it would be the best way to actually find find community is to try and create some.